Alright, this one's week 2, question 2. Now the tricky bit of this question is to make sure you understand what independent events are and then how to calculate some sort of tricky way of getting this value here. We've obviously got the answers in front of us, which is good. Helps us to find out when we've got it right. And they're all any number of events, and they're all got the same probability p, and we're trying to find the expression for the union. So first thing to remember is that an independent event basically implies that the intersect of the two is equal to the probability of one times the probability of the other. It's probably worth just remembering that, and if you think about that as a Venn diagram, all it's saying is that the probability of both is equal to the probability of one, the probability that it's going to be in that one times the probability that it's in that one. And that's the natural kind of way you probably think about it. But if these two things weren't independent, then suddenly that might change. So once you know, say for instance, that probability A means that B can't happen, then once we know it's in A, that instantly says that it can't be in B. So that's just one example of many where they're not independent. And you can't really judge much by a Venn diagram on this, so don't get sucked in if it looks one way or another way. You have to have this either stated or proven somehow. Anyway, moving on. So the one trick that makes this suddenly obvious, if you think about the fact that we know it's independent, and now we'll draw some of these sets of A1, etc. A1, A2. Oh, hard to draw it in here, etc. I think you get the idea. If you're trying to calculate and add up each one of these, then it starts getting a bit tricky. So by far the easier way of doing it is to calculate this using the not area. And what you see is, if you're looking at that area, suddenly it becomes a bit easier when I'll write this out. That area is equivalent of not A1 plus not A2, not plus, intersect with not A2, intersect not A3, dot 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 dot, intersect not AN. And then all we have to do is remember that by this independence rule up here is the same thing as the probability of A1, and remember that of not A1, and that is 1 minus the probability of A1. But if we have a look up here again, the probability of all of these is just going to be equal to P, so it's going to be 1 minus P multiplied by the probability of not A2, which is also going to be 1 minus P. And pretty soon you'll realize they're all going to be exactly the same. So instead of saying 1 minus P times 1 minus P minus P, we're going to put 1 minus P to the, oops, not squared, to the N. And to make this even correct, what we've just calculated there is not the probability of the union, which is what we're after, but we calculated the probability of the outside. So to get the union, we just need 1 minus that whole thing. As you'll see, the answer is up here. So we made it. That's the end of that one.